Good to go.
Good go.
All right. Hello, everybody. Today I'll be presenting on the virtual screening of the inhibition of ABL mutation through analysis of the TKI Ponatinib, presented by me, Mike, and I'll be using Tariq's final research paper to present all the information in this presentation. So I figured we'd start off with the context of the project. The tyrosine kinase inhibitors are the first line of therapy for chronic myeloid leukemia. The first and second generation TKI imatinib drugs were designed after the inhibition of the BCR-ABL protein. The drug mutation T315I was created, and Ponatinib was used to combat it. Ponatinib is able to bind isoleucine tightly at the active site and inhibits BCR-ABL. So moving on to the descriptions and the objectives. Virtual screening was used to determine the future of Ponatinib. With the use of Maestro version 17.1, the target gene was assigned as the ABL gene. Ponatinib was actually recalled within 2 years of being on the market due to its severe side effects, thrombosis being the leading side effect, which is just a fancy way of saying blood clotting. A TKI that has the ability to bind to mutant ABL genes with lower risk side effects is the main goal for this project. So moving on with the research approach, using virtual screening, an analysis of the hydrogen bonds and the ATP binding site of the target protein was conducted. The potential drug stability was found this way. Assessing the interaction energy of the inhibitor and tyrosine kinase receptor led to new details on how the drug will interact with the mutant kinase. And the image on the bottom just shows the catalytic reaction of a protein kinase, just to sort of give you a visual on that. Now, the original aspects for this project start off with targeting the ATP binding site of the ABL gene, which inhibited the BCR-ABL mutant protein. The inhibition should affect the growth of the cancer due to the tyrosine kinase being a phosphorylating enzyme. The molecular dynamic simulation of the protein ligand complex was ran at 10,000 picoseconds, which allowed the visualization of RMSD, the root mean squared derivation, to measure the root distance of corresponding atoms of the two proteins. So the first image in the top right is a simple pie chart showing the distribution of potential mutations on the ABL gene. So the most prominent mutation, which is the lime green color, is the missense mutation, which led to the inhibition of TKI. And underneath that is a simple 2D map of ligand interactions of Ponatinib. So finally, with the results and the conclusion, Ponatinib has the chance to create a resistance mutation. Therefore, a new drug which has the capability of binding in the presence of a primary resistance mutation and ensuring no future mutations will decrease its activity, it should be manufactured. H bonding of Ponatinib resulted in improved docking of the drug on the target protein. And a concluding point is a further understanding of the phosphorylase interaction with the ABL gene will increase the odds of finding a more optimal drug. And just to explain the last two images, the image in the top right is a diagram of the ABL kinase domain and the recorded mutations located on the genes that resulted in a resistance mutation to the TKI drug. Mutation T315I, which is represented in the red in the middle, has secondary resistance, which made the drug inactive, while still allowing ATP binding and kinase activity. And the table below it compares the binding affinity of drugs to the target protein, with Ponatinib having the best score. The next generation drug needs to achieve better affinity to move on with this trial, which is kind of the concluding point from this whole study. And this is the link to Tariq's final research paper, the bioinformatics.
Gotcha. Okay, so maybe I want to take 10 to ask question. Okay, so then your turn, ask question.
see.
You have to ask a question, any question.
Okay. I know.
Okay, no.
It's powerful. How'd you feel?
How I feel? Unsure.
That's fine. That's perfectly fine. Yeah.
Oh wait,
You still have
yeah.
yeah.
I guess.
You asked me about the delta G's.
What were the compounds with the highest alpha scores again? That's that.
Oh yeah. So that actually wasn't included in the bioinformatics paper, but I mean from what I've done within this dry lab, I've only gotten one docking score for the wild type, and that was around negative 14.62
What was it assigned of you?
kilocalories. So
Okay, so the key part you can, I know you have not got the top 5 compound, top 5 compound for the mutant, particularly for the mutant. But in your final written, you assume you got that 5 compound. So in your proposal, you basically propose how to testing that 5 compound. Use the wet lab.
the wet lab.
Yeah, wet lab. And for that wet lab, basically you have to explain how the GoMax toolkit be used and how you design that 5 concentration. And then once you got IC50, how to interpret that those IC50, what look good, what look bad. Because the key thing is proposal, it's not some done research. So you basically make that assumption. You found those 5 compounds. You want to figure out whether or they really has good IC50 compared this existing drug. So this drug you mentioned, it has reverse effect. So definitely if we found a better, replace this one, that definitely will help.
Okay.
Okay, yeah. Because the proposal, you can assume you got that 5 compounds, and then you want proceeding with how to got IC50 for that 5 compounds. So you can work in your especially last 2-week lab on how to got IC50 of that 5 compound. That's your major goal, is proposal.
So even if it doesn't relate to my specific drug, I can still
It's
use it.
related to your specific drug because you want to beat this Ponatinib. This is the target we want to replace it, right?
Okay.
So that basically means in your lab design, you have this one, you have this as reference, then you have that 5 compound through the virtual screening, and then you want got basically the 12 IC50 because the 6 will be on the wild type, 6 will be on the mutant. And once you got IC50, then you propose what kind of IC50 pattern will allow you to conclude the compound you're suggesting will be better than this one. So that's basically kind of the proposal. The core part of the proposal is about what you're going to do and how to interpret the future result.
Okay.
Okay, good. So thanks.